Good afternoon. Today is our first day of our new unit, which is exponents. Make sure throughout all of these mini lessons, you are taking notes, writing down the examples, and writing down key points. Make sure you attend your teacher's virtual office hours and email them questions if you don't understand anything or if you have questions. All right, so as a refresher from the past years, properties of exponents are a refresher. So we know exponents is when we multiply the number by itself. So the big number at the bottom is called the base, and the exponent is also called the power. If you do not see an exponent, and it's just your plain number of 2, a base of 2, there's really an invisible 1. So 2 is the same thing as 2 to the first power. That's going to be really important for today and tomorrow. So 2 for this first example, 2 to the third power just means 2 times 2 times 2. 3 of them. 2 times 2 is 4 times 2 is 8. With the negative in parentheses, this is saying I have to do -3 and raise it to the second power. So we have to be careful. Just because it is a negative doesn't mean our answer is going to be negative, because if I do -3 times -3, a negative times a negative is a positive, so this means -3, that whole negative number, to the second power is 9. Make sure at any point you pause the video and write down important information, steps, and work so that you have it all on your paper to refer to. Okay, so let's look at when we're multiplying with exponents. How would we find the value of 2 to the third times 2 to the second? Well, when I think about what each of those means, 2 to the third power means 2 times 2 times 2. 2 to the second power means 2 times 2. If I combine those, and again, I'm multiplying all of these, if I combine those, I have 2 times 2 times 2 times 2 times 2. I can simplify that and rewrite that as 2 to the fifth power, because I have 1, 2, 3, 4, 5. Well, let's look at our answer is 2 to the fifth, and let's look at my original problem, 2 to the third times 2 to the second. Think to yourself, what's the relationship? Do we see any connection between our original problem and how our answer was in that simplest form with an exponent? When multiplying with exponents with the same base. So same base, I mean that same big number right here of 2. We add the exponents and keep the base. So we saw that 3, when I had 2 to the third power times 2 to the second, it gave me 2 to the fifth. So really this becomes 2. I add my exponents, 3 plus 2, and that gave me 2 to the fifth power. Pause this and write this key point down in your notes. Is this the same with fractions? Absolutely. Just because it's a fraction, a negative, whatever, doesn't mean it changes. I still have the same base, 1/2. I'm multiplying with the same base, so I just have to add my exponents, 2 and 4. So this becomes 1/2 to the sixth power. I need to keep it in parentheses because if I just do this, 1/2 to the sixth power, it looks like I'm just raising the 1 to the sixth power, not the whole fraction. So I need to keep the fraction together in my parentheses, and that tells me I need to do 1/2 times the sixth power, or 1/2 multiplied 6 times. So number 1 says 8 to the third times 8 to the fifth. They have the same base, which is 8. So it's going to be 8. When I'm multiplying, I add my exponents of 3 and 5. So my simplified means I don't need to multiply it out. My simplified version for my expression is 8 to the 8th power. Do number 2 on your own. Okay, I'm multiplying. Remember, when two parentheses are touching like this, that's an invisible multiplication sign. Same basis, so I keep my base. I'm multiplying, so I add my exponents. 8 plus 4 is 12, so 5 to the 12th power is the simplified answer. Try number 3. Okay. 3 is the exact same thing, we just have 3 bases. Hopefully you realize this is where it's so important, where we have to remember this 3 has an invisible 1 to it. So all of my bases are 3, so that means I can just add my exponents of 3, 2, and 1. If you forgot about this 1, correct your answer. 3 plus 2 is 5, plus 1 is 6, so 3 to the 6th power is our answer. Add your exponents when you're multiplying. Do not forget that a single number has an exponent of 1. Okay, and then we're going to do this last one together. This last one is different because I see 2 different bases. I have a base of 9 and a base of 2. I want you to think of this as like combining like terms. I can't combine something that is not a like term. So we talked about adding the exponents when we're multiplying, but it has to be with the same base. I have no other base of 9, therefore 9 to the 2nd power is going to stay just 9 to the 2nd power. I can't combine it with my bases of 2. However, 2 to the 5th times 2 to the 2nd, I can combine because they have the same base of 2. So that's going to be my base of 2, and I'm going to add my exponents. 5 plus 2 gives me 7. That is my simplified answer. I cannot simplify any further. I have no like terms. I don't have any like bases, so therefore I cannot combine my exponents. 9 to the 2nd times 2 to the 7th is my simplified answer. So this question is asking you for the value of each expression. That means I need to find the actual answer, the numerical answer, not leave it in the form with an exponent. So that means I actually have to multiply it out. So I need to do -3 to the 2nd power. We just talked about, again, that's the negative. So when -3 times a -3, if you need to see it multiply it out, you can, is a positive 9. Negative times a negative is a positive. This is the same thing. I'm going to multiply -3 times -3 because it's to the 2nd power, and I get positive 9. A negative times a negative is a positive. And then I multiply 9 times 9, so the value of that expression is 81. Value means no answer. The answer does not have any exponents. See if you can try number 2. Okay, think order of operations just like always. I need to take care of what's in the parentheses first. So there are 2 different ways that you can do this. I'm going to leave the 2 on the outside because I need to do parentheses first. So you can do it one of 2 ways. You can say, all right, using the multiplication exponent property, that means I'm going to add my exponent since I have like bases, and 2 to the 3rd times 2 to the 2nd is going to give me 2 to the 5th power. Then I could figure out what 2 to the 5th power is. And that is 32. And then I do 2 times 32 and I get 64. If we do it this way, which is fine, that gives me a larger exponent. So you might want to do it this second way, which is, again, leave your 2 on the outside of the parentheses, but just multiply. Since we're not simplifying and following the value, multiply each out. 2 to the 3rd power is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, so I'm left with 8. 2 to the second power is 2 times 2, which is 4. So those were much smaller numbers and easier to multiply. Order of operations says parentheses, 8 times 4 is 32. Well, look at that. That was the same thing we got when we added the exponents and did 2 to the 5th. And then 2 times 32 is 64. Make any corrections you need to. And these are the basic steps of how we multiply with exponents with like bases.